Okay, so as I was looking at some of the work that you guys are handing in and some of the questions that are coming in, um, I started to think about whether or not there is an easier way to explain how you figure out whether it's scale factor or how you figure out diagram measurement or how you find the actual measurement, instead of always having to default to setting up the proportion statement. So I'm going to show you an alternate way that you might want to work with these types of questions, and then it's up to you which method sort of makes more sense for you. Okay, so I'm going to look at three different types of questions. So first question would involve you trying to find the scale factor, right? So as a reminder, we have that formula. Scale factor is diagram measurement compared to the actual measurement. So you can think of it, you're really going to be dividing them, or you can leave it as a fraction. So question A here, we have two tables. So we have the original table. Okay, so when we're talking about the original table, we kind of say like this would be like our actual. And then we have the scale drawing. Well, we're kind of calling this our diagram. Okay, so keep in mind, sometimes a question will have it labeled slightly different. So if I want the scale factor, I'm going to have to compare some of the dimensions. So it doesn't matter. I'm going to focus on the height. This has a height of 10 centimeters. This has a height of 4. So if I want the scale factor, I'm just going to write down my formula. Okay, I have it above, so I'll just start to fill stuff in. So diagram measurement, that's the 4 centimeters. So I'll put 4. I'm comparing that to the actual, which is 10. Okay, you don't need to include the units. So the scale factor, we could say it's 4 over 10. Always try and reduce this down. So we can divide top and bottom by 2. So I could actually say it's 2 over 5. And then depends on how you want to leave your answer. That's fine. Or remember, you could write it like this, 2 to 5, or you could write it as a decimal. So you'd also say the scale factor is 0.4. Okay, so for question A, any of these three versions would be good. You could also write it out in words if you wanted. Okay, question B. So this time we have the original. So again, we think of this as the actual, and we have our scale drawing. We think of that as our diagram. Okay, I want to find the scale factor. So I'm going to write down scale factor is equal to. So this time maybe I do the, let's call this our length. So I'm going to be comparing 3 inches and 12 inches. Okay, so scale factor diagram has to go on top. So I'm going to talk about the 12 inches first. So 12 goes on top, and then the 3 inches goes on the bottom. Okay, so you have 12 over 3. Check if you can actually make that into a nicer number. We could divide that, and we would just say that the scale factor is 4. Okay, now on this, if you wanted, so as well, technically as a fraction, it would be like 4 over 1. Or you could also say it's 4 to 1. So what that means, like 4 centimeters of the drawing is representing 1 centimeter of the actual. Okay, so however you would want to state that. And don't forget, this makes sense because if you look at this picture, the original picture was smaller than the diagram. So our scale factor has to be bigger than 1, right? Because the original picture is getting enlarged. Whereas back up here, the actual table, okay, is bigger than the diagram. So our diagram's smaller. So if you're going from an original or an actual and then you're making it smaller, you're reducing it. So that would make sense that now we would have a scale factor less than 1. Okay, so that's the first type of question. The second type, this is where I'm going to explain a different way you can go about this. So another question that comes across a lot is where you want to determine the actual, so some actual dimension given a scale factor and a diagram dimension. Okay, well, here's the thing. That original formula we started with up here, okay, scale factor is diagram over actual. You can actually manipulate it. So if I took that and then solve for the actual, I get this new formula I could use. So I can find the actual measurement by taking the diagram measurement and dividing it by the scale factor. Okay, so we're going to do a couple different versions. It tells you determine the actual height for each of the following, given the following scale factors. So I have this scale drawing. So reminder, that just means I have a diagram drawing. Okay, and I'm told that the height is 6 inches. So based on a scale factor where 1 is representing 3, so based on the question, what this means, so this is like 1 inch represents 3 inches. So 1 inch in the diagram is representing 3 inches of the actual. Okay, instead of you having to set up the proportion statement, let's use the formula. So we could then say the actual would be equal to diagram measurement, which is 6, divided by, okay, the scale factor. Now, what I'd suggest is take this version, okay, so the 1 to 3, write it as a fraction. So 1 over 3. So I'm going to go 6 divided by 1 over 3. Okay, well, you got to be careful. So when you divide fractions, as a reminder, we talk about keeping the first, we switch this to multiplication, and then we're multiplying by the reciprocal. So that's like multiplying by 3 over 1. So then the actual measurement would be 18 inches. Okay, the second one. So if it's 2 to 1, again, best bet, think of this as a fraction first. So that's like 2 over 1. So then our actual, according to our formula, would be the diagram, which hasn't changed, 6 inches, divided by 2. You don't really need the 2 over 1, it's just the number 2. Okay, well, 6 divided by 2 means I would end up with 3. So if my scale was 2 to 1, where 2 inches of the diagram is representing 1 inch of the actual, okay, then what happens is this actual measurement is going to be 3 inches. Okay, so this time we have our scale factor is 0.75. So we are trying to find the actual. We're going to use our new little formula that might help. So diagram was 6 inches. We are going to divide that by 0.75. So 6 divided by 0.75 would give you an actual measurement of 8 inches. Okay, now don't forget we talked about if your scale factor here, right, 0.75 is less than 1, that means whatever your actual measurement was, if you're scaling it by 0.75, that's a reduction. So double check, you're going from 8 inches, it's getting reduced to 6 inches. That makes sense. Okay, whereas this one, you said, or we said the scale factor is 2. So if the actual that we started with was 3 inches and we use a scale factor of 2, this 2 means it has to get bigger. The dimension has to get bigger. So check. It was a 3, it became a 6. That also worked out. Okay, very last one. So this time scale factor is 1.5. So then your actual, and you can tell it's getting kind of repetitive, but I wanted to show all the different formats. So you have the original, or sorry, not the original, the drawing that was 6, and we are dividing that by the scale factor, which is 1.5. So 6 divided by 1.5 will actually give you 4 inches. Okay, check if this makes sense. So you're saying you started with an actual dimension that was 4 inches. You applied a scale of 1.5. 1.5 is bigger than 1, so it should be a bigger picture that you end up with. So I went from 4, and you ended up getting a 6. So that makes sense. It's been an enlargement. So I guess one last thing I might want to add up here, when you're talking about the scale factor, you probably want to use, so I'll put down fraction or decimal format. So the first two, we switched them to fractions, and then the second two, so questions C and D, were actually written as decimals. Okay, so then the third type of question that comes up when you're talking about scale factors, diagram measurements, actual measurements is kind of the opposite. So this one looks at what if you wanted to determine a diagram measurement and you're given the scale factor and the actual. So again, if we took that original formula, the scale diagram, and kind of manipulated it a little bit, we could get the diagram measurement by itself. And what that means is you would actually have the actual measurement, and it's always times your scale factor. Okay, and again, how about I add in here? Usually you want, so I'll put as a fraction. That's not how you spell fraction. So as a fraction or as a decimal. Okay, so this time we have this door. So it's telling you the original is 12 inches. And as a reminder, original means like the actual, so what you're starting with. So it's 12 inches high, 4 inches wide. So what happens if we're told the scale is 1 to 4? Okay, so remember we said change this to a fraction or decimal. So let's just use a fraction. So we'll go, this is like 1 over 4. So then the diagram, if I wanted to draw the diagram version of this door, so the scale drawing, I would take the actual, and again, I'm just going to focus on one of the dimensions. So I'll go with the 12 inches. We would have 12, and then times it by the scale factor as a fraction, which is a quarter. Well, that's like 12 divided by 4. You would have the height of the drawing diagram, so it would be 3 inches. And just to kind of save you a bit of time, I'll just do the calculation for the height. Okay, if you wanted, you could go back and calculate what the width would be. All right, what if the scale was 3 to 1? So 3 to 1, remember, probably wanted as a fraction or decimal. Well, 3 over 1 is just 3. So our diagram would need to be the 12 of the actual, and then we're going to times it by our scale factor, which is 3. So if we were to draw this actual door as a scale drawing using the scale factor of 3 to 1, our height then would actually have to be 36 inches. Sorry, my pen keeps jumping. So this would be 36 inches. Okay, well, does this make sense? Think about it. Your actual was 12 inches. You're scaling it up by 3. So 3 is bigger than 1. So that means what you're drawing has to end up being larger. So 36 is larger than 12. Okay, 2 more. So what if I give it to you as a decimal already? Even easier than the last 2 we just looked at. So you would take your actual, which is the 12, you would times it by 0.8. So this one you would end up with a height of 9.6 inches. Okay, stop for a second, think about that. You started with the actual being 12, you applied a scale factor less than 1, so that means you're reducing it. So it makes sense that you're going from 12, you should end up with a smaller number, okay, because it has been reduced. And then very last one. So what if it was 3.5? Think about it maybe to start off with. If it's 3.5 for the scale factor, this means you're going to end up with an enlargement. So your number has to be bigger than 12. So we're going to go 12 times 3.5. So this would end up being 42 inches in your drawing. So in the diagram that you were drawing for your scale drawing. Okay, so again, options for you. If you like setting up the proportion statements and that makes sense, continue to do that. If you're struggling a little bit and you think these formulas might help you out, okay, you are free to use those as well. And again, some of you might even have another option that works well for you, so you can use that too. Just stick with whatever is making sense to you, as long as you're getting the right answers. And again, if you guys are having trouble, please reach out to me. I am here for you. Fire me an email, and we will go from there. Have a nice day.